Hi, everybody. Welcome to the Exam 1 review. So what we're going to do is I'm going to actually take you through an old exam that I have used in the past. And what's going to happen is if you get the question right, you'll go on to the next question. If you get the question wrong, then you will go to a part of the video where I will describe to you what the correct answer is supposed to be. Okay, so let's go ahead and start with the questions. So question number 1. I calculated the median household income for a sample of professors at CU Boulder. This is a descriptive statistic because it just describes what is the median of this sample. It's not being used particularly to infer anything about the population, it is just describing. It's not a parameter because parameters are only for the entire population, and it says explicitly this is a sample. And in this case, it's not a frequency because it's not how many of anything. It's just saying in this distribution, in this sample of scores, we have a median of whatever, in this case, whatever it happens to be. Question 2. I give a sample of survey. In the survey, I ask participants to tell me about things they own. I ask them to tell me how many cell phones they own. I calculate a number and that I use to guess how many cell phones everyone in the population owns. This is an inferential statistic because we infer information from the sample to the population. Number 3, continuous data does not include nominal. Ordinal, interval, and ratio, we're using all three of those as continuous data. Nominal data is not continuous, it's categorical. Question 4. All right, we're going to look at these data here. What is the frequency of 3? Frequency just means how many times does 3 show up. Now, I'm talking about how many times does it show up in X. In this case, X is the raw score. So we're just counting the 3s. 1, 2, 3s. So the frequency of 3 is 2 because there are 2 people who have the score of 3. Question 5. If I have a positively skewed and unimodal distribution, then the mean is going to be greater than the median. So this is this kind of a situation. If we have a distribution, so let's see if I can get this to work. 1 second. Here we go. So we're going to have a positively skewed. That means that there's going to be a few scores. What just happened there? Oh, it was off the margin, that's why. Okay, let me delete that and try again. So I got positively skewed, so it looks something like this, right? So these positive scores are, these positive scores over here are pulling the average up. The median, the middle, is going to be somewhere around there, right? But the mean is going to be somewhere around here because those positive scores are skewing it up. All right, the mean and the median won't be the same. That only happens in a symmetrical distribution that's unimodal, right? But I guess it wouldn't really matter if it's unimodal in that case. Anyway, the mean will be less than the mode. No, that won't be the case because the mode generally peaks around the middle. That's normally what happens. The mean will be less than the median. And in this case, if it was negatively skewed, that would be the case, but this is positively skewed. Question number 6. Question 6. A bimodal distribution has 2 modes. Bi means 2, modal means modes, 2 modes. That's how many modes it has. Question 7. Question 7. A normal curve, which is a normal distribution, is, well, it's symmetrical. It only has 1 mode. It's unimodal, right? 1 mode. It doesn't represent categorical data. It only represents continuous data. It's a normal curve. Normal curves are only for continuous data. All right. Question number 8. Question number 8. What is the deviation for participant number 1. So in this particular case, what we're going to do is we first need to figure out the mean, because the deviation is just how far away that person's score is from the mean. So we're talking about person 1 here. So that means we're looking at 2. Come on. We're looking at that person's score of 2, and we're trying to figure out how different 2 is from the average. Now this is from a sample, so the average is going to be x bar. So x bar is going to be adding up all the scores and dividing by 6, because we have 6 participants here. So 2 plus 2 plus 1 plus 1 plus 3 plus 3 is going to give us 12, right? So you add them all up, the sum of x is 12 divided by 6, then that means x bar is 2. And you get deviation by getting x minus x bar, x minus the mean. So 2 minus 2 is 0. So the deviation for participant 1 is 0. Number 9, what's the sum of the deviations in any sample? In any sample, any at all, the sum of the deviations is always 0. It's 0. It's always 0. Because when you add up, you'll have as many negative as you have positive, right? You'll have it's the same amount of negative as you do positive, and they have to add up to 0 because they deviate from the mean. It has to add up to 0. Number 10, how many standard deviations are there in a sample? The answer is 1, and only 1, ever. The standard deviation describes the sample. Just like the mean describes the sample, well, so does the standard deviation. It's the standard amount that the scores deviate from the mean. Number 11, considering the data, what's the sum of squares for this sample? All right, so this is the same data that we had before. We already know that the mean is going to be, x bar is going to be 2. So what we need to do is look at the deviations for each of these. Then we're going to square those, then we're going to add them up. So the deviation for participant 1 is 0, because 2 minus 2 is 0. 2 minus 2 is 0. 1 minus 2 is negative 1. 1 minus 2 is negative 1. 3 minus 2 is 1. 3 minus 2 is 1. We're going to square each of those. Deviations squared. So the deviation squared is going to be 0 squared is 0, 0 squared is 0, negative 1 squared is 1, negative 1 squared is 1, 1 squared is 1, and 1 squared is 1. So the sum of squares is going to be adding all those deviations squared up, and that's going to be 4. 0 plus 0 plus 1 plus 1 plus 1 plus 1 is 4. I enter a raffle with 100 other people. There are 3 prizes available. You win a prize by having your name drawn out of a hat. Once you win a prize, your name is put back for the next drawing. Which of these would use the addition rule? Now remember, the addition rule is when you have or this occurring. Multiplication is when you have this and this occurring. So what is the probability of me winning all 3 prizes? That is an addition thing. Prize 1 and prize 2 and prize 3. What is the probability of me winning the first or the second prize? This or that, that's the addition rule that we're looking for. What's the probability of winning the second and the third prize? Notice the and in there. That would be multiplication rule. What's the probability of winning only the first prize? Well, in that case, that's just a basic probability. It's no addition to be done. So the answer is, what is the probability of me winning the first or the second prize? Or is addition rule. Number 13. Imagine you have a normal distribution of a population. The mean for the population is 2. The variance for the population is 4. You have a z-score of 2. What is the raw score of this z-score? Okay, so here's what we got to do. This number 13 is asking us to use, let me show you which one we're using. To get the raw score from the z-score, you use this, mu plus lowercase sigma times z. That is the mean plus the standard deviation times z. All right? So we get the mean plus the standard deviation times z. So let's look at the question again. Here it is. So the mean for the population is 2. So that's going to be our mu, 2. Come on. Where is it? I'm trying to make this thing draw. All right. It doesn't want to draw for me. Come on, draw. All right. So what you'll do is 2 plus the standard deviation times the z. Do we have the standard deviation? We don't have the standard deviation. We don't have the standard deviation here. We have the variance, though, and the standard deviation is the square root of the variance. So this is saying 2 plus the standard deviation is 2 times the z-score of 2. So 2 times 2 is 4, plus 2 is 6. The raw score here is 6. What percentage of the normal distribution is below a z-score of 0? Z-score is the number of standard deviations you are away from the mean. In a normal distribution, we know that that's symmetrical. That means that the mean is right in the middle. That means that we know that exactly 50% are below. So the z-score of 0 is the mean. That means that person's score is the same as the mean. All right? Anything below that, 50%. Anything above that, 50%. 50% below, 50% above. That's how that works in a normal distribution. Number 15. So for the following data, we need to do this equation right here. Give me the sum of x when we start with participant number 2 and end with participant number 4. So what you see right here, that the uppercase sigma is sum of x sub I. Sub I means for the individuals, right? And down at the bottom, we start with individual number 2, and at the top, end with individual number 4. So it's just saying add up the scores for individuals 2, 3, and 4. 4 plus 6 is 10, plus 1 is 11. Number 16. All right, so this is pretty simple. We're going to calculate the mean. So all we're going to do is add everything up and divide by n. So we need to get the sum of x over n. So we need to add up all the raw scores. 4 plus 4 is 8, plus 6 is 14, plus 1 is 15, plus 4 is 19, plus 5 more, that's 24. So the sum of x is 24. Divided by n. N is the number of people in the sample. That's 6. 24 divided by 6 is 4. Okay, number 17. Now for this one, it's really important that you notice that we gave you the deviation. We gave you the deviations, not the raw score. So this actually should have helped you to get the sum of squares. Because what you needed to do is to take each deviation, square it, and add them up. So what you do is you take each of these deviations that we already gave you, you square it, and then add it up. So what we're looking for here is, so these are going to be the deviations squared. 0 squared is 0. 0 squared is 0. 2 squared is 4. Negative 3 squared is 9. 0 squared is 0. 1 squared is 1. You're going to add those up, and that is 14. 1, 4. Come on, give me my 1 back. It's moving them around. It's 14. I don't know why my pen is being stupid. Let's fix that up. Sum of squares equals 14. There it goes down there. Oh, because it's centering it. Yeah, I told it to center, that's why. Okay, so that's what you found. Sum of squares is 14. Okay, now these are the same data that we just gave you. The same data so number 18 has the same data from number 17. Remember, these are deviations. So now we need to calculate the variance. Okay, now this says explicitly this is a variance of a sample. So what we do is we take the sum of squares. So we squared each of these deviations, and we add those up, and we're going to get 14, because the sum of squares is 14. And then you divide it by, not n minus 1. So for a sample, you divide that by n minus 1. N is 6, so n minus 1 is 5. When you divide 14 by 5, you get 2.8. So the variance is 2.8 because you take the sum of squares, divide it by n minus 1 for a sample. If it was a population, we would do n. But it's a sample, so we do n minus 1. Number 19. Consider the following. Again, we got the deviations. We got to do the standard deviation. So this is the same as what we were doing before. All right, it's the same data that we were doing before. We know that the variance that we calculated in 18 was 2.8. So all we have to do is take the square root of 2.8. The square root of 2.8. And the square root of 2.8 is 1.67. Number 20. Calculate the z-score for participant number 6. So we want the z-score for this person right here. Okay? So what this is saying is, first you need to figure out what these are. Now remember, these are raw scores that we're talking about. These are no longer deviations. These are raw scores. So you got to figure out each of the deviations and get the standard deviation and take participant number 6's deviation divided by the standard deviation. So x bar for this is 4. Okay? 4 plus 4 plus 6 plus 1 plus 4 plus 5. So all the raw scores added up gives you 24 divided by 6 equals 4. So then we're going to get the deviations for everybody. So here's the deviations. The deviations are going to be 4 minus 4 is 0, 4 minus 4 is 0, 6 minus 4 is 2, 1 minus 4 is negative 3, and 4 minus 4 is 0, and 5 minus 4 is 1. Then you square those deviations squared. All right, you get 0 squared is 0, 0 squared is 0, 2 squared is 4, negative 3 squared is 9, 0 squared is 0, 1 squared is 1. You add all of those up, you get 14. Remember, so the sum of squares is 14. Okay, the sum of squares is 14. When you divide that by n minus 1, you get 2.8. When you take this, and that would be the variance. When you take the square root of 2.8, you get a standard deviation of 1.67. So to get the z-score, we take x minus x bar over the standard deviation. So we take x, which is 5, minus x bar, which is 4, divided by 1.67. So that is 5 minus 4 is 1 divided by 1.67. And when you get that, it's 0.5976. So if you round it up, you can round it to 0.60. Okay, 0.60. That is the z-score for this person, and the z-score is the number of standard deviations away from the mean that individual happens to be. 21. All right, I got a normal distribution of a population. The mean for the population is 12. The variance for the population is 9. You have a z-score of 1. What is the raw score? Remember, this is what we did before. So we got the mean is 12. So you take the mean plus the standard deviation, which we only have the variance, right? So this is the variance right here. So we need to take the square root of that. That would be the standard deviation. So the square root of 9 is 3 times the z-score of 1, and that's going to give us the raw score. 12 plus 3 times 1 equals 15. So that raw score is 15. All right, number 22. Imagine you have a normal distribution of a population. The mean for the population is 12. The standard deviation is 2. You have a raw score of 13. What proportion of the distribution is greater than the raw score of 13? So what this is asking us to do is look up the z-score on that table. Remember when we did the table with the z-scores, right? We did all those, the proportion, the larger portion, smaller portion, that kind of stuff. So that's what this is asking us to do. So the first thing we need to do is find the z-score. Then we need to find that z-score on the table. So the mean for the population is 12. All right, the standard deviation for the population is 2. Okay, that's good to know. You have a raw score of 13. So first we need to find the z-score. So z is going to be the x minus x bar over the standard deviation. So it's x minus mean over the standard deviation. X in this case is 13 minus the mean, which is 12. In this case, it's mu, not x bar, sorry, because for the population. 13 minus 12, and you're going to divide it by the standard deviation. The standard deviation is 2. So what we need to get is 1 divided by 2, and 1 divided by 2 is 1/2, and that is 0.5. So what this is asking us then is what proportion of the distribution is greater than a z-score of 0.5. So to do this, we go to our table. Here is the table. Let's try and make this table bigger for us so that we can actually read it. Okay. So in this particular table, here is the z-score of 0.5. So what we're looking for, whoa, it's probably because I made that bigger. So 0.5, sorry for that circle. Let me get rid of that just so we don't confuse ourselves here. Maybe it's not going to let me do it. Anyway, you look at 0.5, and you're looking for what's bigger than 0.5. Well, what's bigger than 0.5 would be as a smaller portion. The reason why it's the smaller portion is because 0.5 is above the mean, right? So that means that the smaller portion of this whole distribution is going to be above a z-score of 0.5 because 0.5 is above the mean. That means that the smaller portion is 0.3085. 0.3085. That is the smaller portion, and that is the portion of the population that is above the raw score of, and I can't remember what that raw score was that we started with. I think it was 13. There it is, raw score 13. So the answer is 0.305. Now, if on the exam you say 30.85, be careful. If I say percent, then I want percent, but the actual answer for proportion, I normally want you to give me that unless I say explicitly percent. So give me this decimal for those proportions. Okay, 23. Assume that 50% of the population vapes. What is the probability that 4 or more participants out of 6 will vape? Okay, this is a binomial. You either vape or you don't vape. So these are mutually exclusive, this or that. It's like a coin that you flip, right? So the question here is the same as asking, what's the probability of getting 4 heads out of 6 flips of a coin? It's the same question. So what it's looking for is for us to look at the binomial table. And in this case, the total number is 6. So let's go to the binomial table. Now, if you look right here, the n needs to be 6, and I have an n of 9 right there. So I need to go to the probability of n of 6 right here. Okay? Now, they said that we would assume that 0.5 is the normal probability of people vaping, 50% vape. Okay, so 0.5 is the probability. And what we want to know is what is the probability that 4 or more people will vape. And what this is asking us to do then is to add up, let's see if I can, probably not going to let me mark it, is it? It's to add up the probability of 4 people vaping, 5 people vaping, and 6 people vaping. We're adding up. The probability of 4 people vaping is 0.234375. Whoops. Plus the probability of 5 people vaping, and that is 0.09375. And the probability of 6 out of 6 people vaping is 0.015625. So when we add those up, when we add up those 3 scores, remember that's what we got off the table, that adds up to 0.3438. So the probability that 4, 5, or 6 people will vape if you have a total of 6 people, and assuming that 50% population vapes, probability of getting 4, 5, or 6 is 0.3438, which is 34.38%. Okay, 24. Assume that 40% of the population vapes. What's the probability that 45 or more participants out of 120 will vape? Okay, so the N here is 120. The N is 120. So if you try and go to that let's go look. If we look at this table right here, we would need an N of 120. The highest N that we have is 29. We can't get to an N of 120. So we have to use what's called the normal approximation. And so what we're going to do is we're going to transform this binomial, and it is a binomial, this binomial problem that we've been talking about, this right here, okay? We're going to transform this into z-score and use the normal distribution in the z-score table to figure this out. In order to do that, we've got to do some differences here. So the mean, remember, to get the z-score, we have to do x minus the mean over the standard deviation. Well, we don't have a mean and we don't have a standard deviation, so we use the approximation. The mean is going to be n times p. Now, the p is the probability of us having somebody who vapes. Q is the opposite. So Q would be the probability of somebody who doesn't vape. All right? So let's go ahead and get the mean first. So already we know that 45 is our raw score. So we got 45. Where are you? Come on. Let me get off of this part and see if it's going to help me out. So we want the probability of 45, okay, minus, I don't know why that's off, and I'll put it in a different place. How about that? That'll help me. So it's going to be 45 minus whatever the mean happens to be. Well, the mean is n times p. N is the total number of people. P is the probability that they're going to vape. So what is the probability that 40% of 120 are going to vape? So that's what we're looking for. So we got 45 people. 45 is our raw score minus n times p. N is 120. That's the total number of people times p, which is the probability people vape, was 0.4. Okay, so what that is 120 times 0.4 is 48. All right, so this top part, the deviation is 45 minus 48, and that is -3. 45 minus 48 is a -3. Okay, but what about the standard deviation? Well, we got to divide all this by the square root of n times p times q. N, p, q. N is the total number of people, 120, times p, the probability that they vape, 0.4, times q, which is the probability that they don't vape. Well, we don't have that here, do we? It's a binomial. You either vape or you don't. So the probability that you do vape is 0.4. The probability you don't vape is 0.6. Because all the probabilities have to add up to 1, right? Have to add up to 1 total. So if p is 0.4, then q has to be 0.6. So what this is saying is n times p, so 120 times 0.4, we already know that that's 48, times 0.6. 120 times 0.4 times 0.6 is 5.36656. So -3 divided by, divided by this number right here. -3 divided by that is -0.56. -0.56. So what this is saying is the z-score here would be -0.56. And the question is, what is the probability that 45 or more participants are going to vape? So what we're looking for is, on the normal distribution, we're looking for the proportion of the distribution that is above -0.56. It's going to be the larger portion because this is less than the average, negative, right? -0.56. We're going to be looking at the larger portion. So let's take a look at our table. we need to find negative 0.56. I wish that that would erase. Maybe if I unzoom myself. Well, that's not going to help anybody, is it? I'm going to reload this so we can see it better. And it's not going to do it now. There it goes. All right. So we're looking at negative 0.56. Now, we don't see negative 0.56 here, right? We can't see negative 0.56 because there's no negatives on this table. So instead, we use 0.56 and we think about it the opposite way, right? And so in this case, the larger portion on the negative 0.56 is what we want, things greater than a 0.56. That's this one right here. 71.23, 0.7123. It's saying that the probability that 45 or more people are going to vape out of 120 people, if the general population has about 40% of the people who are vaping, means that you have a 71.23% chance, or the proportion is 0.7123, that you're going to have 45 or more participants out of 120 who are going to vape. So the answer is 0.7123, because we had to change it to a z-score and then use it on the distribution table. All right, thanks everybody.